Welcome back. It is Weather Wednesday.
Not wellness.
Not wellness. Weather. I love alliteration, so it makes it hard when everything starts with a "w." We are talking more about wildfires in depth today and how they can actually create their own weather.
Yeah, images of vast clouds of wildfire smoke towering into the sky become all too familiar in recent active fire years across the western United States. But did you know wildfires can actually spawn their own thunderstorms?
I know, so often people think of a thunderstorm, then the lightning, then the fire, and usually that's what happens. But check out this video that we captured yesterday just north of Kern County. This is a thunderstorm near Lake Isabella, and it had that classic structure like we see in our textbooks. The cumulonimbus cloud breaking the cap, as we say, shooting above the atmosphere to form that anvil. At this point in the mature stage of the storm, that updraft is still feeding the storm, but precipitation is beginning to fall, creating that downdraft. When the downdraft and the rain-cooled air spread out among the ground, it forms that gust front. That's why we always talk about the gusty winds. The mature stage is the most likely time that you'll see hail, heavy rain, that frequent dangerous lightning, strong winds, and even the possibility of tornadoes.
Cool shot. But how do you know if it's a thunderstorm that formed on its own, or if it's created by a wildfire underneath? Well, for that, we turn to these instruments. Here's a time lapse from NASA showing the creek fire near Shaver Lake back in 2020, creating its own pyrocumulus nimbus cloud. Now, that essentially a fire-triggered thunderstorm, which is generated when the intense heat of a wildfire carries smoke up in the stratosphere 5 to 7 miles, yes, 5 to 7 miles above the surface.
Yeah, so it's that smoke and the vapor in the air that reaches the upper atmosphere. It then cools and condenses to form what we call pyro-CB clouds over the fire. Now, some of the moisture is already present in the atmosphere, while some of it is also evaporating from burning plants that are fueling the fire below. So if the fire is large enough, that intense heating can actually generate these smoke-infused thunderstorms. Precipitation and lightning can then occur within these clouds, creating the risk that the fire could expand due to increased wind and, of course, the chance of new lightning-striked fires. Pyro-CB clouds can also generate stronger winds that fan the flames, making the existing fire hotter and helping it to spread.
Now, in some cases, the air may rise so fast that it creates a tornado, sometimes called a firenado. You've heard us talk about that. Or a fire whirl, like this one caught on camera by our sister station, KTLA, during the same fire in the northwestern Los Angeles County area on August 10th. This was 2022. Now, these are all things that fire managers must keep in mind while continuing to try to fight these fires.
Yeah, it's so rare to catch those on tape. Just amazing. NOAA satellites are our eyes in the sky, so that's what we're using to detect and monitor wildfires, as well as the severe weather that may be near them or being created by them.
Yeah, and we've been able to, well, not we, but like PG&E and CAL FIRE have been able to build this vast camera network all around the state of California to kind of help us see when these fires develop. We can see their activity. Kind of cool that we have those resources.
And now AI is getting in the game too, helping us to spot the smoke columns before even human eyes can see it. They can read the temperature gauges and they can see better than our own eyes. It's just amazing.
I know, right?
Technology.
Yep.
All right, we'll be right back.